this is a little bit of a recap of last week. So we were talking about the different ways that we can log data. We have for now two methods, which are Wi-Fi and offline data on the SD card. And both modes of operation will basically differ in how we access the data later on. So either we request the data to our platform with the REST API, or we load the data from the SD card using either scripts or spreadsheets. Today, I will show you how to use Python to load a lot of data to concatenate the data from the SD card without having to open them one by one and going through each one of them in case that you have especially a lot of days, because otherwise it's really cumbersome. Before doing that, I wanted to just show you a couple of little extras. So remember that last day we talked about using R instead of Python, but we used, or at least I showed in RStudio. I don't know if you are familiar with RStudio or not. I honestly don't use it that much. I'm very familiar with Jupyter, which is this interface that I was showing you the other day. That is basically this web interface with cells that you can run and that basically execute code every time that you hit play or shift enter. There is a way for you to install R also in Jupyter, and you can have both of them in the same environment. One tab, for instance, could be running Python. As you can see here on the top right, I'm running Python 3. And another tab could have R. So that is very handy if you want to do, or if you know how to do things in R or in Python. You can even use both of them in the same notebook. There are ways to convert the kernel and, for instance, run R functions within Python, and there are packages for that. I just want to show you a very brief example with the same library we used the other day, but in Jupyter, and then a simple plot that will just plot temperature over time. So for that, we will install and do the same as the other day. So we can install from GitHub the R Smart Citizen R data. And then there is this, I'm sure you know it already, but it's ggplot, which is the grammar of graphics for plotting in R, which is a very well-known library in the language. So we can load both with this cell, and even if it disappears in red, it's just output from the kernel, there's no problem. And then we execute the same instructions as the other day. So we can get the names of the different channels and the units. So this is ADCs, total volatile organic compounds, etc. The units that they have, the sensor that they take the measurements with, and the ID in our platform. We can also get the data with the same instruction as the other day. This probably will take a little bit, but you will see all the requests to the API endpoints scrolling here in a second. And then the rest, here we go. And then the rest basically is just adapting this data into a data frame that we can understand in R. So normally for this type of data frames, you use an index that have the date as a timestamp, and then the different columns represent the data itself. And this can already be fed into a simple plot with ggplot, which is a very convenient way for you to specify different items of the plot. In this particular case, it's very simple. I'm just plotting the temperature over time, but there can be ways for you to customize this, make it larger, add different metrics, and modify and the aesthetics of it, and so on and so forth. But with this, I just wanted to show that you can also run not only Python, but R in the notebook. And that then, if you are familiar with either of them, you can still work and do the same things that we're going to do later on today as part of the legacy of our projects. Okay. Couple of tricks if you want to know from Jupyter, besides from saving, that is quite a basic thing. Here, there's a tab that is the kernel. In case that you have a problem, you can always interrupt the kernel with this instruction here. So it will basically stop whatever is executing. Imagine that you have a loop that is doing a function and then you want to stop it, you can just interrupt it. And if you want to, for instance, save or restart everything and clear all the outputs, you can simply click here, restart, and then everything will be clean and ready to go for a new run. And you can edit it and very simply just clean the whole state. One recommendation is that if you are planning on sharing the notebooks, either you intentionally share the data that you want, so you leave everything with the outputs and everything, or you delete it before sharing, because otherwise the notebook stores everything. So all the data will be inside, all the plots, and maybe some internal paths of your computer that in some cases could pose a small security issue because, well, you probably are printing here tokens or things like this. So make sure that whenever you share the notebook, keep in mind that this is not just a script, but that it also contains data. So whenever you upload it online, make sure that there's no data or anything that is compromising you or your computer. Another example before we go into the SD card data is a very basic one, but I show you here. I won't go through it, just mentioning it. That is then in the examples folder of the GitHub repository. You have the example number 10 that basically talks about how the data is organized here and the different types of data sources that you can access to. Actually, this is outdated, and you can also get data from Nilu iflinks API, which is the okay. Basically, here you have different devices that showcase the properties that you can see from the data itself, and then the concept of the test that I was talking about the other day, but with explanation in a little bit more verbose way. So if you want to dig in the different details of how this is working, you can run through this little example, and we'll go through the different aspects.